It says that when Heisenberg was on his deathbed, he said, "When I meet God, I'm going to ask him two questions. Why relativity and why turbulence? I really believe he will give me an answer for the first." It may be a little bit exaggerative, but these words truly show how hard the topic we are going to talk about is. The turbulence. Turbulence, by the definition, is a fluid flow which is unsteady, irregular, semi-random, and chaotic. Simply, it means turbulence is an unpredictable flow. Turbulence happens everywhere in our daily life. For instance, when a piece of paper dropped in air, turbulence appears. When your car is running on a road, there will also be product. You may not feel it almost of the time, because the turbulence usually is not such obvious to us, unless you are on an airplane. Although it is like an intouchable ghost, our scientists still have an equation to catch it. In 1757, scientist Leonhard Euler published his discovery about fluid dynamics, the famous Euler's equation. I have to emphasize that Euler's equations are not Euler's formula, although they are all discovered by the same Euler. What a genius he is. The equations are a set of a couple differential equations that can be solved for fluid problems by using calculus. At that time, scientists just thought, finally, we can solve some turbulence problems. But they were over-optimistic, because Euler's equations can only describe a fluid system in a perfect, which means no friction and no viscosity condition. The theoretical values predict hugely deviated from experimental values. Viscosity is found to be a very influential factor in turbulence. To correct Euler's equation, Navier-Stokes equations are created. Somewhat surprisingly, given Navier-Stokes equation's wide range of particle uses, it has not yet been proved that whether in three dimensions a solution always exists, or if it does, whether it is perfectly smooth or not. These are called the Navier-Stokes extents and smooth problems. Navier-Stokes equation is one of the 7 problems which were set to US dollars for 1 million price each for a correct solution. Now we can appreciate what turbulence is and how it works. But why bother to try so hard to find these equations? Humans are busy. It is because if turbulence under all circumstances can be predicted, our life will be fascinating. The weather forecast will be completely correct since now we can imitate how turbulence in winds moves. We can even imitate or even produce storms by changing the temperature or pressure in some area. Plans can be much more stable since undesired clear air turbulence now can be evoked. Nevertheless, the most important change it brings to us should be the completion of the safety method. The full name of safety method is Computational Fluid Dynamics Method. Since 1916, when computer technology developed at a high speed, computing simulation and calculation become a very important part of the research of fluid dynamics. Computers are used to perform the calculation required to simulate the interaction of liquid and gases with surfaces defined by boundary conditions.